Welcome to our YouTube channel Advanced Learning Center. This is the disclaimer of my video. Today I am going to discuss about the control system subject paper, which came in the year 2023 and semester examinations in State Council for Technical Education Assam. Assam Polytechnic যিবিলাক এণ্ড ছেমিষ্টাৰ এক্সাম হৈছিলে 2023 তাতে কুৱেশ্যনবিলাক আহিছিলে myself Tashir Ali Sheikh. Contents of today's videos is CS question paper of 2023, solution of control system part A, solution of question number 1, fill in the blank, solution of question number 2, write true or false, solutions of question number 3, answer on one sentence, solution of question number 4, choose the correct answer, solution of question number 5, match the following. So this is the question paper and semester examination 2023 5th semester new syllabus, subject code 8509, control system. There are two parts, part A and part B. This is the 3 hours duration. In part B there are 25 marks is there. So here is 5 questions, 5 marks is in each question. First is part 1, fill in the blanks, 5 question 5 marks. Then true or false, here is also 5 question 5 marks. Answer on one sentence or draw figures, here is also 1 marks. Next is that means choose the correct answer, here is also 5 question 5 marks. Match the following, question number 5, here is also 5 question 5 marks. So all the question will be described in our later slide one by one. So in part B there are 45 marks is there. So in the first questions in the part B is define open and closed loop systems with one example of is 3 marks. 6B, using the block diagram reduction techniques, find the transfer function or CS by RS of the following diagram, here is also 3 marks. 6.3, find the Laplace transform of this equation. This is the equation is given, they need to find out the Laplace transform. Next is find the Laplace transform of equation, this one, determine the characteristic equation of this one, find the, using the signal flow graph, find the transfer functions of this signal flow graph. Question number 7, define tensometer, give the transfer function, derive the transfer function equation of AC tensometer. 7B, what is the primary function of DC motor, list 2 disadvantages of DC motors. 7.3, discuss and derive the transfer function of lag lead compensator with a suitable electrical network. Next question is question number 8A, what is steady state error, find the steady state error for the RAM input signal. 8.2, for the step RAM and parabolic input signal, prepare a constant and corresponding steady state error value table for type 0, type 1 and type 2. 8B, find the velocity error coefficient KV for the given equation. Equation is given, for that one we have to find out velocity, that means K of A. In OR option is there, what is peak time, here and discuss the disadvantage and advantage of static error coefficient method. Question 2, for a system having GS into HS equal to this one, find type of the system, error coefficient and error due to this one. Question number 9, for a system given below, write the characteristics equation of the block diagram. Find Wn, sigma, Wd, Td, Tr, Tp, Mp and T of S. Or analyze the second order systems with an appropriate diagram. Also find the S values of the characteristics equation. Question number 10, determine the characteristics equation of this one and also examine the stability of the determined characteristics equation using Raoult's method. So this was 10 questions. Next we will give the solution of question number 1. Fill in the blank. So see the first question. Find an automatic washing machine is an example of what? An automatic washing machine is an example of open loop control system. Dash can be treated as an amplifier in control system. DC motor can be treated as an amplifier in control system. Next one, C, for type 2 system, steady state error due to RAM input is equal to 0. See how it is become 0. So our question is for RAM input and type 2 steady state error. So this is the type 2. RAM input is this one. The steady state error is 0. Okay, so therefore answer is 0. If you remember the table, you can find out or you can answer any question. Okay. Next is with a negative feedback. The system gain and stability is decrease and increase. So if the feedback is negative, as we know that the feedback, if will be negative, the transfer function will be 1 gs by 1 plus gs into h of s. Okay, so if feedback is negative, that means s is negative, this will be plus. So once it is plus, the gain will be what? This transfer function is nothing but it is the gain of the system. If it is plus, that means this lower term will be become large. So when this lower term will be become large, this thing will be decrease. So that's why gain will be a decrease. And stability, when the gain will be decreased, the stability will be increase of a system. Okay. So next, location of dash has a direct effect on stability. Location of poles will be direct effect on the stability. Next, solution of question number 2, write true or false. So first question, stability can be found for characteristics equation. Yes, from the characteristics equation we can find the stability. So this statement is true. Total number of poles and 0 are not changed by the use of tachometer. Yes, this statement is also true. The poles and 0 does not change even we use the tachometer. Steady state error coefficient method can be used for unstable system. So this statement is false, right? Because we use the steady state error for the stable system. For the stable system we use the steady state error coefficient, not for unstable system. So this statement is false. So positive feedback improves the performance of automatic control system. Yes, for positive feedback it improves the performance of automatic control system because error becomes less. So for a bounded input system, if produces output bounded output, then the system is said to be stable. Yes, so this statement is also true. One point was there in Rauther's criteria. Bounded input, for the bounded input, if produces the bounded output, then the system will become stable. So this statement is true. So next come to the question number 3. Answer on one sentence. So see the questions. First question, the Laplace transform of positive side function ft is given by 0 to infinity ft e to the power minus st dt. So here is asking about the positive side. Positive side, that means it will be start from 0, not from minus infinity to plus infinity f of t e to the power minus st dt. It is not start from minus infinity, it will be start from 0, because in our question it is given positive side function. Okay, so next, for a type 1 second order system, the value of peak overshoot will be e to the power minus pi sigma by root over 1 minus sigma square. Okay, so this is the formula for peak overshoot for type 1 second order system. Next, the number of individual loops in the signal flow graph is 6. So see how it becomes 6. Number of individual loop. Okay, so number of individual loop, first is this one, next first is this one, next is this one, next is this one, next is this one. This way it will become this way. Next is here to here. Okay, so next is it will be here, this one, this one, this one, and this one. Okay, next is last one, it will be this way, this way, and this way. So these are the 6 individual, 1 2 3 4 5 6. So therefore answer is 6. Next is write and disadvantage of Routh-Harris criteria. So the disadvantage of Routh-Harris criteria are, it is very complicated and time consuming for solving higher order systems. This method is unable to find the exact number of poles located in the right half of S plane. Third disadvantage, it is very tough to predict the marginal stability. So it is these are the 3 disadvantages of Routh's criteria. Next question, Routh array of the characteristic equation is given by this one. Okay, so this is the equation given. So from these equations we have to find out the right hand side of the S plane. So it is 0. So how many number of roots lying on the S plane? So answer is 0. How? So if we find the equations using this one, so this will be s square x cube, means here coefficient is 1, s square, so coefficient is 5, s, so it will be 10 and 3. So our formula is for calculating this one, our formula is this multiply 5 into 10 means 50 minus this minus 3 divided by this 5. So it will be how much? 47 by 5, so it will be 9.2, 9.4, sorry. So that's why here it is 9.4. again here it's not given, it is intentionally we can put 0. Again this multiply by the minus this, so 9 by 3 divide minus 5 by 3, so my 3 into 9.4 minus 0 divided by 9.4, so it will be remaining again 3. So if you check this on this line, in the first coulomb there will be no sign change. So if in the first coulomb there is no sign change of sign, that means from positive to negative, if there is not shifting, then it is called, this system is called stable system. Okay, so because there is no changes, so if there is no changes of this system, that means no roots are lying on the right hand side of the aspirant. So no means, that means 0, so that's why we can put here 0. Next, solution of question number 4, choose the correct answer. So here see the first question, human system is a multivariable feedback control system, a open loop control systems, a single variable control systems, a complex control systems. A human control system, human system is a multivariable feedback control systems. Next, the Routh array of characteristics equation is s to the power 4 s3 plus 3s square plus 2s plus 7. The system is marginally stable, unstable, stable and conditional stable. So the same thing, the system is unstable. Let's see, s to the power 4 means 1 coefficient, s to the power 3 1 coefficient, s square coefficient is 3, 2s means s coefficient is 2, 7, then there will be no, so intentionally we can put 0. So now the same formula, this minus this, so 3 minus 2 divided by 1 equal to 1, so we have written 1. So again here this will be 2 minus 14 minus 3 0 divided by 2, so again here it will be 7. 2 into 7 means 14 minus 0 divided by 2, so it will be 7, so here it will be 7. So next is 2 minus 7 divided by 1, so it will be minus 5, so here it is minus 5. Again this will be 7 minus 0, 2 minus 0, so all are 0, 0 by 7 means it will be 0. So again this one minus 5 into 7, that means minus 35, minus 1 into 0 means 0 divided by minus 5, so again here it will be 7, so here it is 7. So answer is as there is a sign change in the first coulomb. If you notice, in the first coulomb there is the sign change, here there is a sign change. Okay, so in this first coulomb, here it is in 5 of s, here is a sign change. So the system is, if there is sign change in the first coulomb, then we can say the system is unstable, so that's why answer is unstable. Okay, so if in the first coulomb there is one sign change, therefore the system is unstable. Next, the number of sign change in the entities in the first coulomb of Routh's array denotes the number of roots of the characteristic polynomial in the right hand plane, and the number of open loop poles in the RSP, or number of zeros of the system in RSP, or the number of open loop zeros in RHP. The answer will be, if there will be sign change in the entities of the first coulomb of the Routh's array, there will be the number of roots of the characteristic polynomial in the right hand side of shift হয়ে যায়. So সেইকাৰণে আমাৰ ফাৰ্ষ্ট this first option is right answer. Okay. Next is, if the gain k of the system increases, the steady state error of the system will be decrease, increase, may increase or decrease, or constant. So answer will be decrease. The thing is that, so here if gain of the system is increase, the steady state error. So here k is nothing but it is the gain. If gain is increases, that means this value will be decrease, steady state error value will be decrease. So that's why if k values is increased, that means this become very high in all the steady state error equations. So this value will be become less. So that's why one is the correct answer. Next, question number 5. The characteristic equation of the unity feedback system is given by this one. The system has one pole in the right hand S plane, has no pole in the right hand S planes, exhibit oscillatory nature, and is asymptotically stable. So has no pole in right hand S plane. See the how it is. There are two options. One is there is no right hand poles in the right hand S plane and exhibit oscillatory nature. So see the solution. So this is our characteristic equation. So S3 coefficient is 1, S square coefficient is 1, 4s S coefficient is 4, 4 and 4. So our formula is this minus this into this minus this. So 4 minus 4 means what? Divided by 1, it is equal to 0. So that's why we put 0. So again this one is intentionally put 0. So again the same thing, this into minus this. So 0 by 0 means 0. So in the right hand of this coulomb there is no sign change, so has no pole in the right hand of S planes. Also become both the part become 0. So that's why it is exhibits oscillatory in nature. Okay. So this is the answer. Solution of question number 5. Match the following. So match the following list A and list B. AC servo motor A S plus 2 by S plus P. Lag network plus minus 12 to 15%. Lead network K by S into 1 plus TS. Delay time 1 plus ST1 by 1 plus ST2. Settling time 0 to 50%. So the answer is, so AC servo meter, it will be K by, that means is equal to this one. Okay. And lag network is nothing but it is this one. Okay. And lead network is equal to, it will be this one. Okay. And delay time is 0 to 50%, and settling time is plus minus 12 to 5%. Okay. So this is the correct answer. This is the correct answer sequence. So thank you for watching this video. Please subscribe, like and share with your friends, those who are studying diploma in electronics and telecommunication in Assam Government Polytechnic colleges. So share with your friends so that your friends will be benefited. Thank you so much.